Absolute value functions and graphs. When we talk about graphing absolute value functions on the coordinate plane, first we want to look at the parent function. So when you have y equals the absolute value of x, we're going to have vertex at the origin. And then if we substitute in some values for x, absolute value of positive 1 is 1, absolute value of positive 2 is 2, and then let's put in some negative values. Absolute value of negative 1 is positive 1. The absolute value of negative 2 is positive 2. We have enough points here to get an idea of what our graph is going to look like. So when we connect these, it extends to the right forever, going upwards at a slope of positive 1. On the left side from the origin, it extends upwards at a slope of negative 1. So let's take a look at the general form of the absolute value function. So y equals a times the absolute value of x minus h, absolute value plus k. Now a, h, and k, we're going to find out what they represent in terms of the absolute value function. The vertex, we're going to use the variables h and k. So I need you to notice that here the h has a subtraction in front of it, but the k has a addition in front of it. That means that whatever value is substituted for h, we actually want the opposite of what it looks like. So if you see minus 1, h is actually positive 1. If you see plus 1, h is going to be negative 1. K, however, because it has a plus sign in front of it, that value is going to be exactly what you see. So if we see plus 2, k is positive 2. If we see minus 2, k is negative 2. So when we look at our parent graph, the vertex is the origin, 0, 0. When we talk about the opening, I want to know, is this absolute value function, this V shape, is it opening upwards or is it opening downwards? Now in our parent graph, this is opening upwards. But the way we're going to decide by looking at the equation is based on the sign of A. So we want to know whether A is positive or whether A is negative. We don't actually care about the value of A. We just want to know, is it positive or negative? So if A is positive, it's going to open upwards, just like our parent function, because we have a positive 1 in front of the absolute value. And if A is negative, it's going to open downwards, so this V would open downwards. The width, we're talking about how wide or how thin is our V. So here, if the absolute value of A is greater than 1, it's going to be thinner, meaning our V is going to be very skinny here. If the absolute value of A is less than 1, our V is going to be wider. Okay. So in our parent graph, the absolute value of A is equal to 1. So we have that invisible 1 here. So that's why we have the slope of positive 1 to the right and negative 1 to the left. Let's work out a few examples of how to graph these absolute value functions. So the first thing you want to do when you see your function is determine the vertex. So we said the vertex is determined by hk. H is going to be the number that's inside the absolute value behind the x. We don't have a number there, so it's going to be 0. The k is going to be the number that's outside. And remember, we said it's the same sign as you see. So plus 2 means positive 2. So we're going to find that point 0, 2, and that's going to be our new vertex. Then from there, remember, we don't have any change in the opening upwards or downwards or it being thinner or wider. So we want a slope of positive 1 to the right and a slope of negative 1 to the left. And just remember that it needs to look like a V. So once we have those points in, we can go ahead and connect those points to create our graph. Like so. Next, we just want to write the domain and range in interval notation. So remember, the domain, how far left, we're going to go left forever to positive or to negative infinity. How far right, we're going to go right forever to positive infinity, and infinity uses parentheses. For the range, the lowest y value is positive 2 included, And our highest value, this is going to go up forever towards positive infinity with a parenthesis. Let's take a look at example 2. Again, first start with the origin. The x value is going to be inside, represented by h, and we want the opposite of what it's showing. So since this shows plus 3, we actually want a negative 3. Our k is going to be outside, and since we don't have anything, we're going to have 0. So first, plot your vertex, negative 3, 0. Next, you want to look in front of the absolute value, and our a is positive 1, so we don't have any change in the opening or the width. So to the right, go with a slope of positive 1, to the left, a slope of negative 1, and then we can go ahead and connect those to make our absolute value function. And then we'll write the domain and range. Again, domain goes to negative infinity, and to the right to positive infinity. Our range, the lowest y value is 0 included, and it's going to go up forever to positive infinity. We're going to work out just a few more examples. So here, you don't have an h and k. Since there's no h and k, that means our vertex is going to remain at the origin. The only change we see here is, look at a. It's negative. So that tells us that it's going to open downwards. Our a is still 1, so it's not going to change in width. So the fact that it opens downwards just means that instead of having a slope of positive 1 to the right, it's going to have negative 1 to the right. And instead of having a slope of negative 1 to the left, it's going to be positive 1 to the left. Then we follow the same steps. We're going to connect our points to graph our absolute value function. And then our domain, again, going forever to the left, going forever to the right. And then this time, our range is going to change a little. The lowest value, this is going to go down forever, so it means it's going towards negative infinity. And then the highest y value is 0 included. Now lastly, let's go through this example. Here again, we have no h and k, so our vertex is at the origin. This time a is positive, so we know it's going to open upwards, but we have a change in value of a. Now the way I want you to consider this is like slope. So slope needs to be a fraction, so we're going to make this 3 over 1. And instead of our slope being positive 1 to the right, we're going to make it positive 3 over 1. So we're going to go up 3 over 1, up 3 over 1. And then to the left side, instead of going up at a slope of negative 1, we're going to go negative 3. 1, 2, 3 over 1, 1, 2, 3 over 1. So remember, the shape of the absolute value function always needs to be a V shape, and it's going to be mirrored through the vertex. So here's our graph, and then we can write the domain and range. It's still going left forever, and to the right forever. And the range, the lowest value is 0 included, and it's going to go up forever to positive infinity. Now let's do these examples that have a few more steps in them. This first one, hk, we have the opposite of what's showing, so positive 3, negative 1, positive 3, negative 1 for our vertex. And then we want to take note of a, so since this is a positive 2, positive means it's going to open upwards, and then 2, that changes our slope. So up 2 over 1, up 2 over 1, and also to the left, up 2 over 1, up 2 over 1. And then you can go ahead and connect the points. Then our domain and range. Forever to the left, forever to the right, our range, our lowest y value is -1 included, and it's going to go up forever to positive infinity. Lastly, let's work on this one. We have an h, -1, k of 0, so our vertex is -1, 0. And then, take a look here. We have negative, which means it's going to open downwards, and then our slope change of 1/2. So we're going to go down 1 over 2, down 1 over 2. And same, down 1 over 2 to the left, down 1 over 2 one more time, so that we can connect our points to create our graph. Now let's write the domain and range. Forever to the left, forever to the right. Since this is going to go down forever, our lowest y value is -infinity, and our highest y value is 0 included. Here we want to write an equation for the graph that's shown. So first let's list the information we know. Our vertex is 3, 1, and then we have this opening upwards, and we have a slope of 2 over 1. So when we insert that information into the standard form, we have y is equal to positive 2, absolute value x minus 3, absolute value plus 1. So let's go ahead and try the second one. Again, we want to list the important information first. -2, 2 is our vertex. And then this is going to open downwards, which means a needs to be negative. And when you take a look at your slope, this is 1 over 1. So we have y is equal to -1, and we don't have to write the 1. So we'll just put the absolute value mark. X minus, since this is a -2, we need to make this plus 2. And then outside, we have a plus 2. That's it for this lesson. I'll see you in class for more practice.